October 29th, 1969, the Advanced Research Projects Agency Network delivered its first message communication from one computer to another, forming what we now know as the Internet. A series of computers connected to one another, forming a global network in which any one of these computers can communicate, allowing for information from the World Wide Web to be easily accessed within seconds. For this to work, a common language is required for the network, enabling accurate functionality and pinpoint accuracy. This language is known as TCP/IP, or rather a Transmission Control Protocol or Internet Protocol. This language creates a unique address of numbers for each computer, which manages to separate the 4.48 billion users that are currently on the Internet into a string of numbers. IPv4 or Internet Protocol version 4 was physically limited to only giving 4.3 billion users a unique address. Now we have IPv6, which raises the limit and allows for more unique users to have access to the Internet. The Internet origins from server farms around the world, 100 million of them, but not all specifically used for the Internet. These server farms are nothing more than regular, high-powered computers with hard drives connected together to create large volumes of storage where information can easily be written and read from. This is the source of the World Wide Web. Large cables, as thick as soda cans, run through the world's oceans and cities to create the global network, a physical connection to and from web-based server farms. Internet service providers, the companies who charge a monthly subscription in exchange for the Internet, are a lot like step-down transformers in an electrical grid. They take these large data cables and split them up in various amounts of routers and switches, allowing for more users to be connected. These switches are responsible for downloading and uploading packets to a broader network of switches which connect to the web-based server farms. A packet is the delivery method of the data. When a user from the United Kingdom sends an email to a person in Japan, the second the user presses the send button, that email is broken up into small packets, each around 1000 bytes in size. These packets contain information which consists of instructions for the network switches to follow. The packets contain the email that was written by the user, as well as the IP address it came from, and the IP address of the recipient. A numbering system is also at play to help the packets reconstruct without errors when they arrive to their destination. The packets are then received by your internet service provider, where the industrial grade routers and switches decipher the information and forward these packets to servers and switches around the world using physical cables to get them delivered to the specified location. The reason why packets are used is because they allow for data to be transferred throughout the global network. The switches then choose the best route possible for each packet, meaning that a part of the user's email can run through Europe and the other part through the North Atlantic Ocean and over the US to reach Japan. Using packets reduces the load around the world's internet system and helps balance the workload evenly, allowing for fast data transmission. This translates well for the end user, as they can open pages and watch videos with reduced loading times. Another reason for the use of packets is that the system offers a redundancy. If one line of data transmission was to fail, the data would not fail to deliver, as the packets can be rerouted and delivered using another internet line, which ensures the data is not lost or corrupted. This complex but rather straightforward system is how you are able to watch this video or send an email. The whole process happens in the blink of an eye without any errors. Has your curiosity been fulfilled? If so, leave a comment down below, and if you're curious about more, then check out our social media for daily facts. Also, don't forget to subscribe for more educational content and hit that bell icon to stay up to date with future uploads.